Hello and welcome. This is just going to be a quick video to demonstrate this HP 5532A frequency counter. This is probably among the very first solid state frequency counters ever produced. It was introduced in 1961 and it was part of a series of units that included the 5232A, which is basically the same except with a neon column display, and also the 5212A and 5512A, which had a lower maximum frequency. So for those it was 300 kilohertz, whereas for this unit and the 5232 that's 1.2 megahertz, and also only five digits on those units. As you can see here, this one has a nixie tube display, 6-digit. If we zoom in there, we can see just how nice those nixie tubes are. Very nice sort of end display tubes. So you know the pins are on the opposite side from the display, and also it has neon lamps for the frequency here. Now, if you notice here, this one, which I got on eBay, it essentially works. The only thing that may be a bit wrong, aside from it was very dirty, and I'm still in the process of cleaning it up a little. But as you can see, it does not gate the output, so it does not latch the value that is counted. You can see it counting. Which is a bit odd, because from what I've read it's supposed to gate that, but I don't have a service manual or any kind of manual except for calibration, so I'm thinking I might just leave it the way it is, because it's actually working pretty well. If we look at the face here, over here we have the sensitivity. So right now I have it on check, and the internal oscillator is 100 kilohertz. So if we look, oh yeah, and there's the input, of course, BNC. And if we look over here, that is obviously the selection of range and function. So we have I had it first on manual, which just counts here, and you can well, now it's not, oh yeah, start and stop there. Now we started again, and it's counting based on the internal oscillator. So we have that. We also have different frequency ranges, of course, from 0.01 to 10 kilohertz, or kilocycles, KC. This is how old this is. We also have period. So as you can see, this is measuring in microseconds, and you have different ranges here. You can see it's 1 microsecond, and we have millisecond. So there's that. Then this, of course, this potentiometer is used to adjust the sort of sampling rate, display rate. You can go from really slow, and it'll blink this neon light every time it displays, up to pretty fast. In fact, it can get so fast that it never finishes counting, like this, or like so then it's just going. Whoops. Yeah, so in this form it's not very useful, just because you can see it's going way too fast and you can't really read the display, so you'd want to turn this down. It also, of course, has a reset, which is mostly useful on the manual mode. So if we look inside here, I've taken the top panel off. You can see it's kind of gold inside. This one, the panel's not in the greatest shape. I tried to clean as much of that kind of tape residue off as possible, but still a bit on it. Now you can see here there was 2 millimeter thick foam for holding the boards in place. This had decomposed and become just basically powder, so I gotta replace this. That's not a huge deal. If we look at the inside here, you can see everything is very nicely laid out with removable boards that are socketed, and so we have 6 identical display boards, or not quite. I think they're identical. This one says 504 and 401, so this one might be slightly different. Have various other boards, and they're all using discrete parts. There's no integrated circuits, and germanium transistors, from what I have read. I'll have to verify that, but it sure looks like all metal can germanium transistors. And we'll have a look at one of these boards closer in a little bit. You can see this actually looks like it's completely original. I can't spot a single part that looks like it's been replaced on this thing. Original electrolytic caps, original open fan here. Let's see. You can see this. The fan has an aluminum blades on the end of a little, I think, shaded pole induction motor here. That's really, you would never see that in a modern, like modern anything. Looking around, yeah, we can see a bunch of electrolytics. Some of these may have, maybe past their prime. But so far I am actually considering just leaving it as is, unless I can find a service manual. There's no free online service manual, so maybe I'll buy one. But for now, I'm just amazed how well it's working. So just looking in here, you can see all of the board slots have the indicator of the number and the type of board that goes in it. And a lot of see, there's no waxed paper caps in here, from what I can tell. I don't think that's a waxed paper. I could be wrong. This one, for some reason, I don't think it is, but it could be. But instead, a whole lot of these little guys, which look to me like perhaps mica. So. And if you look at this, these little orange caps have glass beads on their leads, which I have never seen that before. I wonder why they did that. Some of the transistors here you can see are gold-plated legs. They have gold-plated legs, which is nice. The boards, some of HP's old boards are have gold-plated traces. These ones just look tinned, but still extremely nice. They are phenolic paper boards, but you see, yeah, I mean, they don't have solder masks. They just have tin traces. Here's another look near the back. You can see the fan. I did a little bit of blade reshaping because it kind of had been messed up. There's a vent back here, which you can see. All the resistors, by the way, too, they're carbon composition, which in these HP units I found tend to be pretty good. They're not always good, but so far they've been pretty good. This thing, I think this may be a crystal. It has 2 leads coming out of the bottom, which we'll see in a second. Here is the bottom. You can see most of what's down here is there's the electrolytic filter capacitors. Presumably they're mostly filters, if not all. Then we have, of course, the connectors for each of the boards, the edge connectors. Gold-plated pins. Very little flux residue. Looks like they really cleaned up after themselves when they soldered. I mean, this would have been basically handmade to a large extent, even if it's in a factory setting. Down here, there's that possibly crystal. It's just got two leads there. We can see there was a dead cockroach in here. Cockroaches don't even live in my part of the world, so that was kind of interesting. Looking at the back here, two fuses which appear, couldn't quite tell if they're original, but they do look old. We have here a port for a digital recorder. Now, of course, the kind of digital recorder that this thing used, or still could use, of course, was a paper feed recorder. So, you know, with a print wheel and a roll of paper, and it would just print out the values at some given rate, presumably, and you know, this would have been the interface for that, probably some kind of parallel interface. Of course, the digital recorders are impossible to find at this point, basically, and although you could also use it. It says digital recorder, but another thing you could use it with is a digital to analog converter, and these seem to show up more often on eBay and such. So that's kind of interesting. Of course, there's the fan vent. We have this power, which is not an IEC cord. This is one of these weird 3-pin HP cords. Voltage selector. Over here we have adjustment for the internal oscillator, and also changing between the frequency standard, internal and external. And of course, you know, if there's nothing plugged in, it doesn't really do much, but yeah, there's the plate there. Yeah, so how about we, let's do one last test here, actually measuring the frequency of a signal given into it. Okay, so now we have a connection here between the input of this frequency counter and the Longway LW1641 function generator, which of course is only the highest quality. Certainly comparable to this HP. But anyway, it's giving an output here 12.76 kilohertz, and if you notice, it actually has a 6-digit frequency counter. However, every time you change the mode here, the decimal place stays in the, or no, the decimal place does move, but you essentially are not gaining any more digits. You pretty much are always stuck with 4 digits, unless you're in the high range and you tune it above, and then you'll get 5, but you'll never get to 6 unless you're measuring some external frequency. So anyway, if we look here, it's saying 12.78. This guy is saying 12.79. Now they're both saying 12.79. And that's of course with the same precision. But if we do this, we can have greater precision on this HP here. And you can see it count here. So 12.798, and so yeah, now this is saying 12.80, 12.800, because of course this function generator is slowly warming up and increasing in frequency because it's just so stable. And finally, if we do this, we will this is going to take forever, but we'll see what it gets. 12, 13, nope, didn't like that. Here, let's go, let's turn that down. Yeah, okay. No, it still is not stopping there. Too bad. Let's try, let's go down to 1K and then go to this range. So now it should count to 1.276. Nope. Okay, maybe this range is not stopping for some reason. Alright, I've cleaned inside here now. I took out some of the boards. These ones I left because they are quite difficult to remove, it seems. This piece may have to come out, these screws, maybe, I don't know. I don't think it's really worth it because I was able to clean in there with a paintbrush anyway. But if we look at what we got here, so here's the board here. I'm guessing this is for the nixie tube power supply. You have this good old 200 volt camp here and a big mica cap there. Here's another mica, and you can see these traces are tinned, and you can also see how thick they are. They're really very thick with the tinning. You can see here we have another board. Yeah, I think these are mica capacitors mostly. Some little Motorola transistors. I looked up some of these transistor types. They are, of course, germanium PNP mostly. This one, this 1850-0062, that's germanium PNP. You can also see that we have some germanium diodes here with bands on them, color bands, which is interesting. As you can see, these are equivalent to the 2N404A, so that's germanium PNP. This is an interesting board. We have two neon lamps, which you can see lighting inside. It doesn't say what they're for, but there's a 2N169A, which is germanium NPN, and other parts there. Ideally, if I was doing a restoration, these electrolytics would be replaced. But maybe someday. But for now, I'm probably just going to keep it as is. I'll at least wait until I can have get a service manual to do work on it. 'Cause it does, obviously, the 10 kilohertz range is not quite working properly.